Okay, this is warm-up 9.8.2. We're going to find the exact values of both sine of 75 degrees and cosine of pi over 12 radians. So the easiest way to do these is if they happen to be special angles that are on the unit circle. So look at that, I got a unit circle right here because I would just be looking for the y-coordinate for the sine, so 75 degrees, but 75 degrees isn't on here. It's somewhere between 60 and 90 degrees. So I can't look at the coordinate with those special angles. And that's where the sum and difference identities are going to come in. So I can do both of these problems using sum and difference identities. Okay, so let's work on sine of 75 degrees first. So since 75 degrees isn't on here, what I want to try to do is add two of these angles that are on here or subtract them in order to get 75. And the first thing that's jumping out to me is 30 and 45. So I could think of sine of 75 degrees as the sine of 30 degrees plus 45 degrees. Okay, and these are going to become the A and B when I'm using this formula up here. I'm adding two values here, and I'm using sine. So I'm going to use this format. So my A and my B are going to be 30 and 45. And of course, you could write that as 45 plus 30, and then that would reverse the A and the B. It won't matter ultimately, okay? So I'm following this format here. I've got the sine of A. Well, A is 30 degrees. Times the cosine of B, using this formula right up here, and my B is 45 degrees, plus the cosine of A times the sine of B. And B again is 45 degrees. Okay, I just fit it in there. Okay, and I can find all of these. So remember, for sines, I'm just looking for the y coordinates at those different places, and for cosine, I'm looking for the x coordinates at those different places. So then I'm going to use my unit circle. Okay, so 30 degrees sine, well, my y here is 1/2, so that means that all of this is equal to 1/2. Okay, and then cosine of 45 degrees, well, the x value there is √2/2. Okay, and then 30 degrees, I'm looking for the cosine. So that's the x value is √3/2. And at 45 degrees, I'm looking at the y, which is for the sine, that's √2/2. Okay, and then I just need to simplify this. So let's multiply straight across on when I'm multiplying fractions. So a lot of times I'll see people write this as √2/2. Well, it's √2/4. Don't forget 2 times 2 on the bottom, right? And then I've got √3 times √2. Well, you could do this, right? Which means that's going to be the square root of 6. Okay, and then I can combine these into one fraction because I've already got the same denominator, so that worked out nicely. Okay, and I can't really simplify that any further. That's the exact value then of the sine of 75 degrees. Okay, let's try this cosine one. This one's a little trickier, not because it's cosine, that doesn't really make it any more difficult, but the fact that it's in radians sometimes makes it a little trickier because it's harder to think what can you add or subtract to get pi over 12, okay? So first thing, pi over 12 isn't on the unit circle. So that means I do need to find something I can either add or subtract. So I'm just going to start playing. I'll move this out of the way for a second. I'm going to start playing around with pi over 12. Well, maybe I'll use this corner up here. So pi over 12. Well, I could think of that. I'm thinking, well, maybe that could be, 2 pi over 12 minus 1 pi over 12. Okay, but when I do that, I could reduce the this one, pi over 6, and pi over 6 is on the unit circle, but I still have a pi over 12 in there, and pi over 12 isn't on there, so this is no good. So that's not a combo that's going to work, so let me try something else. What if I did, say, let's try 3 pi over 12 minus 2 pi over 12. I'm just kind of playing around with these. And then these, I can reduce both parts here, so let's do that. Pi over 4 and pi over 6. And then if I get the unit circle back out again over here, pi over 4 is on here, and so is pi over 6. So that's going to work out, right? So now I can think of this as the cosine of pi over 4 minus pi over 6. Okay? And that can be my a and b, and now I can use the formula. So this is a difference identity because I'm subtracting in here my a and b. So then I'm looking up cosine. And so I've got, sometimes I like to just put in blanks. So cosine of something times cosine of something else. And then plus sine of something times sine of something else. And of course that something and the something else is my a and my b. So my here I've got a and b, so pi over 4 and pi over 6. Okay, and then in the second part, a and b again, pi over 4 and pi over 6. Okay, and from here on out, I'm going to be using my unit circle again. So again, I'm going to be looking, when it's cosine, I'm looking for the x values at those positions, and for sine, I'm looking at the y values for those positions. Okay, so let's see. Cosine of pi over 4. Well, here's pi over 4. I'm looking at the x value. That's root 2 over 2. Okay, and then the cosine at pi over 6. That's the x value, root 3 over 2. Okay, looking for my y value for the sine at pi over 4. That's root 2 over 2. And y value at pi over 6 would be 1/2. Okay, and then I just simplify it the same way I did on the last problem. So this is going to be root 6 over 4 plus root 2 over 4, and I've got a common denominator. And it actually is the same answer from the last problem. It's just the two values on the top are in a different order. That's just a coincidence there, but there's not really that many different ways these can shake out with the sum and difference formulas for sine and cosine. Okay, that's the end of the warm-up, and I'll see you next time.